I took a few problems off the physics classroom and I thought I'd go through the first 4 of them. Okay, so we need our equations. That's 1 over F equals 1 over dO plus 1 over di. That's the mirror equation. The magnification equation states that the magnification is equal to hi-ho di-dO. Most importantly, do not forget that negative sign. It's a game changer. Number 1, determine the image distance and image height for a 5 centimeter tall object placed 45 centimeters from a concave mirror having a focal length of 15 centimeters. Unless you're a genius, you're not going to be able to calculate it in your head. You're going to have to draw a picture, something that you're going to do a lot in physics. So we're going to draw a concave mirror, their principal axis, and I know, it's just beautiful. Okay, the object is 5 centimeters tall. It's placed 45 centimeters away from a concave mirror. Now, this is known as the object distance. And in the last video, I said that if the object distance were positive, then you're kind of inside the cave. So we're moving 45 centimeters in this direction. Okay, so wherever that object is, it's 45 centimeters. I'm actually going to locate the focal point first, because I get a lot of perspective from doing that. It says a focal length of 15, so I always like to draw the center. I know the focal length is half the radius, so the focal point is going to be right here. It's going to be right between here. If it's a focal length of 15, I know that this distance is 15 centimeters. Now, if the object is 45 centimeters away, think about what that means. It means that this is 15, this is another 15, and right about here, another focal length away, is our object. And that object is 5 centimeters tall. I'm just going to put 5 centimeters tall. All right? Now, think about this. We have the object distance. We know that this distance, this entire distance, is 45 centimeters. So we have the object distance. We have the focal length. So which of these equations do you think we're going to use? So we have F and we have dO. Well, I'd use this equation right here. It's generally the case. You're going to use that one first and then the second one. So I guess you should rewrite the equation. Unless you don't want to, then don't. Your focal length is 15 centimeters. Your object distance is 45 centimeters. And you don't know your image distance. All right, now I'm going to skip a lot of algebra and pre-algebra because honestly, you guys are too old for them. So you subtract 1/45 from both sides and you do some math and you get that 2/45 is 1 over di. Here's a little math trick for you. If you want di by itself, notice that the numerator and denominator just need to switch places. If I take this and switch places, all I need to do is flip the 2/45. So if 2 over 45 is 1 over di, 45 over 2 is di over 1. Another way of thinking about that, I know I'm going into the next problem, but if you have two things equal, you can cross multiply them. So 2 times di equals 1 times 45, which is just 45. And when you divide both sides by 2, di is 45 over 2. That's an alternate way to show the exact same thing. All right, so that's 45 over 2, which simplifies to 22.5 centimeters. Now, that 22.5 centimeters is positive. You don't have to put a plus in front, but some people do. If the image distance is 22.5, that signifies that the image is 22.5 away from the center, in this direction. Okay, so we can kind of plot that. If 15 is right here, 30 is right here, 22.5 is actually right in the middle. It's right here. But I don't know the height. I don't know the height of the image, and that's what we're trying to find. So I know I know sorry about this. I know that my image is 22.5 centimeters away from the mirror. Since I know the image distance and the object distance, and I also happen to know the height of the object, I know 3 out of 4 things to make this equation work. Now, I want to make something very clear. This equation, you can use any or all parts of this equation, which means m is equal to hi over ho, which is equal to negative di over do. I don't have to use this part of the equation if I don't want to. I can use this relationship that says that the proportionality between the image height and the object height is equal to the inverse, or the negative, image distance over the object distance. So I'm just going to use this portion of the equation, which means I'm going to copy it down here. Hi-ho is negative dido. It's a fun thing to say. Now, I want to know what my image height is. So I'm going to leave that as a variable. I know that my height of the object, it tells me it's 5 centimeters tall. So I'm going to put a 5 right here. Negative sign, I know that my image distance is 22.5 centimeters. And my object distance, well, it's 45 centimeters away. We can just look at our picture. I don't care how you solve that. HI comes out to be negative 2.5 centimeters. I'm not going to go through it, but you can if you want to. What does that say? Well, negative 2.5 centimeters represents our image height. Remember, height is upright if it's positive and inverted if it's negative. So since this is a negative sign, we know that our image starts here. It's at a distance of 22.5 centimeters away from the mirror, and it's 2.5 centimeters. It is half of our original starting object. It's half of that in the negative direction. So that would actually be the physical location of our image. Let's move to question 2. Now, I hope you're pausing the video, or I should have told you this before. I want you to pause the video after I draw the picture for each one of these and just predict, based on what I taught you in the last video, predict where the image would be. Okay, not exactly where, but you should have guessed that since this object is outside the center of curvature, the image should be somewhere between the center of curvature and the focal point. You should have also predicted that the image would have been inverted. Now, these actual numbers represent like the actual position and the actual orientation of the image, but you should be able to predict that beforehand. All right, so now it's the exact same question, only the object is placed 30 centimeters from the concave mirror. If I ever choose to make this video shorter, I'm just going to copy and paste this. All right. That's 15 centimeters, which means that this is 15 centimeters, and 15 plus 15 is 30. The object is placed 30 centimeters from the concave mirror, which means the object is right on the center of curvature. Okay, and it's still 5 centimeters. I'm not going to bother doing the calculation, okay, because there's no point. From the last video, I told you that if the object is right on the center of curvature, A, it's going to be the exact same height, just inverted, and B, it's going to be located at the center. So the image is going to look like this. If you actually did the calculation, you'd come up with 30 centimeters, but is it a positive 30 or a negative 30? Well, it should be a positive because you're still going in this direction. So it's a positive 30 centimeters for your object distance, or your image distance. And as for the height of the image, it's the exact same height, just in the other direction. So it's negative 5 centimeters. All right. This one is placed 20 centimeters away. So we're going to put the center right here and the focal point right here. I should note that I included a PDF document of some other problems that I want you to do. Okay, so 20 would be somewhere around here. If you need help or if you need a key, you need to check your answers, just let me know on that. All right. We're probably going to start the first equation just like we always do. It's somewhere between the center of curvature and the focal point. So if you were to predict lost for the image, predict the location, orientation, size, and type, real or virtual. So I'll pause the video and just see if you can do that from memory. If you can, I honestly think that's all they're going to ask you in terms of a concave mirror. But just in case they ask you these calculations, it's not erasing. All right. I know my focal length. I know the object distance. I don't know the image distance. My focal length is 15 centimeters. My object distance is 20 centimeters. If I subtract that, and if I switch everything up, I'd get 1/60th is 1 over di, which means 60 is my image distance. So 60 centimeters for that. And that's a positive 60, so it's going to be 60 in this direction. All right. So now we're going to use the other equation to calculate the image height. I should have left more room. I know, I'm a bad person. All right. Hi-ho equals negative dido. So compare the ratio between the image height and the object height, and that is equal to the inverse, note that negative sign, between the image distance and the object distance. The only thing we don't know and we want to find is the height of the image. We know the object height. Okay, the object height is 5 centimeters. The image distance we calculated before, which I erased, but it was negative 60. And the object distance was 20. So however you calculate that, however you do the math, you're going to get negative 15 centimeters. And that's a negative 15, so the height is going to be 60 away, so probably somewhere over here, and it's going to be negative. And it's going to be 3 times the size of this image. Last problem for this video, yay! All right. Determine the image distance. This time it is 10 centimeters away. It's 10 centimeters. So let's draw the last picture for this video. Okay. Here's my center. Focal point. That's 15. Not even going to bother to label it anymore. You should just know that's 15. 10 would be somewhere over here. And pretend that's not slanted, and that's 5 centimeters. Same equation as before, 1 over f, 1 over do plus 1 over di. My focal length is still 15. My object distance is 10. Gives it to us in the problem. It's placed 10 centimeters away. And we want to know the image distance. If you do the math, you'll actually get negative 1/30th is 1 over di. So di is negative 30 centimeters. The image distance is 30 centimeters in the opposite direction. So this would be 30. This would be negative 30. So it's somewhere over here. Okay, now we're going to use the other equation, the magnification equation, to solve for the image height. All right? Hi-ho is negative dido. I know everything but my image height. My object height is always 5 centimeters for this case. My image distance we calculated as a negative 30. This is what I was talking about before in the previous video. This always just innately has a negative sign. But my image distance is a negative 30. So this is negative 30. The reason that's so important is because the negatives are going to cancel and you're going to be left with a 30 over your object distance, which we said was 10. So I'll go ahead and do this one for you. The negatives cancel out, as I said before, and you get 30 over 10, which reduces to 3. So however you choose to do this, I would multiply both sides by 5. So the 5's cancel. And your image height is 30 over 10, which is 3, times 5, which is 15 centimeters. Now, we have an image distance of negative 30 centimeters. So if this was 15, this would be about 30 centimeters in the other direction. And the image height is 15 centimeters. So it's 3 times whatever we said for here. So it's going to be really big. Right? Hopefully you were able to calculate that, or at least give me a rough estimation before we actually did the calculations. In the next video, I will do like 2 more problems on this just to make sure we have it. Hopefully in the description link, I included a PDF to some more practice problems that I would really appreciate it if you did. Great practice. I'll see you in the next video.